Today we are going to discuss about the reaction iron with copper sulfate. Iron and copper sulfate reaction is a popular and well-known chemical reaction which we all have studied in the chemistry textbook. So exactly which reaction is happening here? Iron and copper sulfate reacts and it gives you ferrous sulfate and copper solid, means copper metal, as a precipitate. To understand these reactions, I have performed a simple reaction at home. So first I have made a copper sulfate solution. It's a blue color clear solution. Then I took an iron nail. Then I dipped this iron nail inside the copper sulfate solutions, and it should be dipped completely in the copper sulfate solution. Now let's see what happens. So this is the initial state when I have just dipped a iron nail in the copper sulfate solution. After 1 hour, you can see this blue color solution now gradually turning into greenish yellow, and you can see this nail, iron nail, is no more shiny. You can see some brown color deposition over the iron nail. Now after 2 hours, it's almost yellowish in color, and iron nail is completely looks like a brown in color. And when I took a top view image, we can see that there are lots of brown colored particles are moving around. So that means the reaction is happening in this way. So this is your initial reaction when you add a iron nail in copper sulfate solution. Then after around 7 to 8 hours, when we observe the reaction mixture, we can see it's almost like a brownish or yellowish in color, and the nail has completely converted into a brown color. Means brown color deposition has taken place. This kind of reaction is taking place at room temperature without supplying any heat or pressure from the outside. So this kind of reaction is known as spontaneous reaction. So this reaction, like iron reacts with copper sulfate, give ferrous sulfate and copper, is a spontaneous reaction where you don't need any heat or pressure or any catalyst. It just happens at room temperature. Now here we can see that actually I have tried to filter out so that the copper metal which are deposited, we can visualize it properly. So this is a filtration process. Now here you can see after the filtration, so these are the copper metal which is settled down the bottom of the glass, and this is the filter paper. Also we can see that precipitate, brown precipitate, is nothing but the copper metal. This is your pure copper metal, and this is the clear filtrate solution which should be the ferrous sulfate solution. Let's explain the reaction. Iron reacts with copper sulfate, it gives you ferrous sulfate and copper metal. So here the oxidation state of iron is 0 and the oxidation state of copper is +2. After the reaction, the ferrous sulfate forms with the iron in +2 oxidation state and copper in 0 oxidation state. So here from iron to iron ferrous sulfate, the oxidation number is increasing, so it's an oxidation reaction. And from copper sulfate to copper, that oxidation number is decreasing, +2 to 0, so it's a reduction reaction. So this is an example of redox reaction. This is also an example of displacement reaction. Now, we also can explain this reaction in terms of oxygen addition. Then I think a few students can understand that why it is oxidation reduction, those who doesn't know about the oxidation number. Now here you can see in the reactant side, iron, and now after the reaction it converted into ferrous sulfate where oxygen is added. So that means iron gets oxidized. Now in the reactant side, copper sulfate having the oxygen. After the reaction it become copper. So that means oxygen get removed. That means it's a reduction. So I think now you understand that one reaction can be classified into different types of reaction. It may be a displacement reaction, it may be a redox reaction. And we also can explain the redox reaction in terms of oxidation number. And we also can explain with the addition of oxygen and removal of oxygen. Now I think one question is coming to our mind that why this particular reaction is happening. Why iron and copper sulfate is reacting, it giving you ferrous sulfate and copper. And the second question is obviously coming to our mind that if we add the copper nil instead of iron nil, if we add the copper nil, and here if we take the iron sulfate, then what is going to happen? Is there will be any reaction? So now let's explain the first question, that why this particular reaction is happening. So to understand that thing, we have to explain the electronic configuration of the iron and copper. Now iron, when it is in elemental state, the valence electron is 4s2 3d8. Here you can see this is 4s2, this is 3d8. So 2 unpaired electrons. Now in case of copper, the valence electrons are 4s1 3d10. This is the electronic configuration. Now when copper in +2 oxidation state, so 1 electrons from the 4s and 1 electrons from the 3d will be removed. So the electronic configuration of the valence orbital will be 4s0 3d9. Now when iron converted to iron +2, so in that case 2 electrons from the 4s will be removed. So it will be 4s0 and 3d8. Now when copper in elemental state, the electronic configuration of the valence orbital is 4s1 3d10. So this is a stable electronic configuration because when d orbital is completely filled, means d10, this is called a stable electronic configuration. Now here you can see when copper in +2 oxidation state, it is d9. That means just copper needs one more electron to fill the d orbital. So I think now you already understood that why this reaction is happening in terms of electron acceptance and electron donation. Now here you can see when the reactant side iron is 0, it's 4s2 3d8, and copper +2, so it is 4s0 3d9. Now when the reaction is happening, iron become iron +2 and copper become copper 0, where copper 0 is 4s1 3d10. So that's like a driving force. Copper +2 is in d9 state. Now copper just need one more electron to fill the d orbital. So one electron is filling the 4s and one electron is filling the d orbital. So it become a d10. Now let's understand the reaction once more in terms of electron acceptance and electron donation. Which element is donating the electrons and which element is accepting the electrons. So here you can see iron means 0 in elemental state 4s2 3d8. So iron is losing the 2 electrons to give iron +2, Actually, you don't write the reaction in this way. We write that iron give you iron plus 2 electron. Now these 2 electrons are going to be accepted by the copper plus 2, means copper sulfate solution, copper in plus 2 oxidation state. So now copper plus 2 is going to accept these 2 electrons and then it will be copper metal. So the net reaction is that iron plus copper plus 2. Here we can cancel these 2 electrons. Then iron plus copper plus 2 is giving you iron plus 2 plus copper. So that means iron is losing the electron, that means iron is getting oxidized, and copper is accepting the electrons, so that means it's undergoing the reduction. So I think now it is clear to you that why this particular reaction is happening and why it is a spontaneous reaction. Because if this reaction happen, copper plus 2, which is in the 3D9 state, it can convert to 3D10 if it convert to copper 0. And that's the driving force for the reaction to take place at the room temperature. Even using this concept, we also can explain the reduction potential. Like here you can see that means iron and copper, if we compare the iron and copper metal which is undergoing the reduction and oxidation faster, we can see iron will oxidation faster, losing the electron. So iron reduction potential will be negative. And the copper has more tendency than iron to get reduced. So that means copper reduction potential will be positive. So I think now you also understood in the electrochemistry point of view why the reduction potential of iron is negative and why the copper reduction potential is positive. Now coming to the next question, that if we do a opposite reaction, means we are adding the copper needles or copper nails in the ferrous sulfate solution, then what is going to happen? Is there will be any reaction? Now copper in elemental state means electronic configuration is 4s1 3d10, means d orbital is completely filled, and iron plus 2 means 4s2 3d8. So in this situation, d orbital is completely filled and which is a stable electronic configuration. So now copper 0 doesn't have any tendency to lose electrons and to disturb the stability of the element. That means this is the thing is not going to happen, that copper sulfate plus iron metal. Because if it is a copper plus 2, then it will be 4s0 3d9. Then why copper 0 will be going to copper plus 2 to disturb its stability when it's already quite stable because d orbital is filled? That means there will be no reaction if you add the copper needle in the ferrous sulfate solution. So I think now you have understood that for each and every chemical reaction, why this particular reaction is happening, there is some reason behind that. And always try to understand and explore the scientific explanation behind a particular chemical reaction. Thank you for watching this video. If you have any chemistry related queries, you can contact me to this email ID chemistry.affinity@gmail.com. Thank you.